ability that we are looking at and the core component. But they always try as much as they can to bring in the types of numbers because they happen to be very, very important. In fact, it's very rare to find a question on numbers where they just say list the types of numbers just openly like that. It's either they give you a range or sometimes they put in the probability concept or the sets. So most questions that we pass, we work out in sets, they will have a type of number or types of numbers that you need to remember. And obviously, if you miss out one type or one item, sometimes you mess up the whole diagram. So my first question is a question on sets. Actually, I have a Venn diagram here, but the question is whereby my E, which is my main set, it is a set that is made up of the numbers 2, 4, 8, 16, 32, and 64. So when we just look at those numbers, we should try as much as we can to remember them, the way we know them. Some of them, they belong to more than one classes of numbers. Some of them is just one class, but this is where it is very, very important. So my set A is a set of square numbers. Square numbers, a result of multiplying a number by itself twice. And my set B is a set of cube numbers, a result of multiplying a number by itself 3 times. Now in cases where you are given the main set, then the subsets are described. Like in this case, it is always important to list them first so that when you answer the questions, it will be easier. It's easier to remember, or it's easier to represent them when they are listed. So in this case, we are supposed to use the information to complete the Venn diagram. In other words, we are putting the information on a Venn diagram. So it is very, very important that we pick out our square numbers from the list. The first one I can see. You always put your curly brackets. The first square number is 4 there. I can see 16. And I can see 64. And in the second one, cube numbers, I can see the second one there, the cube of 2, 8. And I can see 64. Can't see 27, it's not part of the set. So these are the elements of sets A and B. Now we want to put them in a Venn diagram. So if you check, each time you want to do a Venn diagram, the first thing you look for are the elements that are common, elements that belong to the intersection set. If I look at this, I can see my 64. It belongs to the 2 sets. So if I can, now to put it in the Venn diagram, it belongs to this region, which is the intersection set. So I put it. So I can see that this is the boundary for set A. So what I do is, after putting the common elements, I'll just check what else is remaining. I have my 4 and I have my 16. So in sets, it is always important to note that the boundary of A determines the elements of set A. So I can see if I'm to neglect or to put aside set B or the main set, I can actually see that my square numbers are 4, 16, and 64. Then on the side of B, I can see that 64 is already in. What is remaining is 8. I put it because B has 2 elements only, and I can see if I can just go through the boundary for B, I have enclosed all my elements in set B. So what will happen now is I go back to my main set and try and check. Now, suppose, because in a typical exam situation, you will be having your list in your question paper. You can actually cancel out. 2 is not in, so I write my 2 outside here, right? I move on. 4, I included it. I also included 8, and 16 is in, but I did not write any 32. Then 64, I used it. And it's always wise to cross-check, because all the elements that are in the main set, they should be represented on the diagram once. So what is important, or what you might do, you should always count like 1, 2, 3, 4, 5, 6. I must have 6 elements. Then we go 1, 2, 3, 4, 5, 6. Then I'm sure that all my elements are in. And if you don't want to count, you can just try and match. Do I have a 2? Yes. Do I have a 4? Yes. Do I have 8? Yes. 16? Yes. 32? Yes. And lastly, 64. That makes it, a total of 6 elements. So this is how we approach a question like this. If there are more questions after this, sometimes it can be another question like an element is chosen from the main set. Write the probability that it belongs to A. That's where you will see that when it comes to such questions, all these, they belong to A. And if it is about B, all these, they belong to set B. And if it is about not belonging to A or B, it's these two. And if it is the intersection, I can see it's 1 out of 8. So that's how we basically interlink the types of numbers, sets, and probability. Now, this is the end of question 1. I now want to move on to my question 2. Now, in question 2, we have our E, our main set, is X, such that X is a positive integer less than 20. This is very, very important. Now in sets, it's just about the language, less than 20. And if they are positive integers, we are basically talking about numbers 1 up to 19. So we are also given set A, the subset, in set builder notation, which combines symbols and descriptions. X is an even number, while in set B, X is a multiple of 3. So we can see the presentation. And please note that this means that anything that is within this boundary belongs to set A. And sometimes before you rush to answering questions, try and find out. It's always the case that these things, they make sense. If these are even numbers, so this is our boundary for even numbers. And if these are multiples of 3, and this is the boundary for B. And when you check, these are the numbers that will not belong to A or B. They are neither even numbers nor multiples of 3. Now, getting back to the questions, the first one says to write down the number of elements in A. Now, our number 1 is the number of elements in A. This is a question on the set language and set notations. If we are to find the number, yes, we count, but our answer is also just a number. We are counting the elements in A, so 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 9. And when we move on to question part 2, list the elements of set B. So the difference is there, we are writing down the number of elements, which is just a number. But when we move on to B, it's list the elements. And each time we are listing the elements of a set, we always list the elements, but we enclose them in set braces or curly brackets. So item 2, this is our set B, and this is equal to, you put your curly brackets, and in your curly brackets, Remember, our set B is the multiples of 3. So we begin with 3, and then 6, 9, 12, 15, and 18. And we put our curly brackets. That's how we answer set B. It's written list, but we should remember our language and our notations. Then part 3. One of these 19 numbers is picked at random. Please note that they are talking about 19 numbers because it was less than 20. Is picked at random. Work out the probability that this number is. Part 3, A. Not in set A and B. Not in set A and B means it does not belong to set A as well as B. So out of 19, we can count 1, 2, 3, 4, 5, 6, 7. So our answer is going to be 7 out of 19. These are the numbers that are not in A and B, and that's how we express probability as a fraction. And the number that is in A union B. A union B, it means we take up all the elements of A and all the elements of B, we put them together, and we do not repeat elements because they are in the intersection. So it's a question of also counting physically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements out of 19. So our probability is 12 out of 19. Then the last part of question 2. The last part of question 2, it says, complete the statement. A intersection B is A. And there is a statement that we have to complete, and this statement is given in set builder notation. Remember, if it's set builder notation, if you check the top part of it is in symbols and part of it is descriptions. So we are not listing those elements. We can see them. All we need to do is to see them. We identify them. Remember, we are trying to look at the types of numbers, and we should try as much as we can to be able to identify them in given situations. So in the intersection set, there's 6, there's 12, and there's 18. What do we know? What are these numbers? What do we know them for? 6, 12, and 18. These are multiples of 6. So to complete this statement, we can actually say, this is part 4, A intersection B is equal to combined symbols and descriptions. X is a multiple of 6. That is a perfect description of those 3 numbers. And someone might think, oh, we did not put the limits. As long as we have our E, the E has already pegged the limit for us. So it's just a question of saying a multiple of 6. The limit is within positive integers that are less than 20. So that was the last part of our question 2. Moving on to question 3. Now question 3 reads, Jane has a fair spinner in the shape of a regular hexagon. The spinner is numbered 2, 2, 3, 4, 4, and 5. We can see the illustration of the spinner. So Jane spins the spinner. Find the probability that the spinner lands on. Item 1. An even number. So, as I've said before, it's always important to note the total number of items in any given set of numbers. In the case of probability, we can cross-check. These are 6 numbers, and the fact that this is a regular hexagon, it's a fair spinner, it means it has 6 equal spaces. So this is actually out of 6, just like in our die. So, but this one is not numbered 1 to 6, it is numbered 2, 2, 3, 4, 4, and 5. So, number 1, the probability that it lands on an even number. It's a question of counting how many even numbers that we have. So, we have 1, 2, 3, 4. The 2 2s and the 2 4s, they will give us a total of 4. 4 out of 6. Now 4 out of 6, you can still write it as 2 out of 3. It's acceptable in its simplest form. The second one says the number less than 6. Numbers less than 6. I think we came across a question like that. We check, we find out that all the numbers that we have in this set, they are less than 6. So the probability is any number that we pick, it's quite certain that we're going to get a number that is less than 6, because so the probability is 1, which you can also express as 100%. Thirdly, we want the probability that we spin and then we get 1. And as we check, you can see there is no 1 on our spinner. This is impossible. And when it's impossible, our probability is 0. Again, I remind you that probabilities range from 0 up to 1. So it's 0 when it's impossible, and 1 when it is certain, then all these other fractions depending on the chance. Then the fourth one, the probability of picking or landing on a factor of 36. Factors of 36, numbers that can be divided into 36 without leaving a remainder. Now if I look at all of them, it's only 5, which is not a factor of 36. So it means 5 numbers out of 6 are factors of 36. And when we move on to the fifth one, again, it's a square number. When we look at our spinner, we can see a 2 is not a square number, a 3 is not a square number, but we have a 4, and we also have another 4. So 2 numbers out of 6. 2 out of 6 are square numbers. Remember, you can still simplify, and you can still make it 1 out of 3. That's our question 5. Question 6. We want to pick or to point at a number which is a cube number, a result of multiplying a number by itself 3 times. We check 2 is not a cube number, 3 is not a cube number, 4, 5. We do not have any cube number on our list, which means this is impossible. And when it is impossible, the probability is 0. And finally, item 7, a prime number. A prime number, which is a question that I said we must always be careful with, because if you check all the questions that will include a prime number, these are the questions where they always put 2, because I've mentioned it in the previous lesson that 2 is controversial, not really controversial, but most of us, we tend to think that 2 is not a prime number because it is an even number. So you have discovered that in almost all the questions where they are talking about prime numbers, they include 2. So if you are counting, you can see that 2, 2, 3, and 5, all of them are prime numbers, which will give us 4 numbers out of 6. And if we can reduce it, it becomes 2/3. Normally with probability, answers are acceptable, even if they are simplified, but it's always a good principle to simplify your fractions. So this is my last question on sets and probability. I believe we had all the practice that we needed, and I keep on repeating that we really need to know our types of numbers, because we can easily miss the required number, because all these questions that I have, most of the questions that I had, they were 1-mark questions. And each time you are given a question and it's 1 mark, it's just correct answer only. You miss the type of number, you miss the probability, you miss the mark. This concludes my lesson for today. Thank you.